Ammonia is an important compound of nitrogen and hydrogen. Let's see how ammonia is prepared in the laboratory. Ammonia gas is usually prepared in the laboratory by gently heating ammonium chloride and slaked lime, or what is chemically known as calcium oxide. Ammonia gas is lighter than air, hence it is collected by the downward displacement of air. As it is highly soluble in water, it cannot be collected over water. On passing ammonia gas over quicklime, that is calcium oxide, it dries the gas. First, let us discuss the physical properties of ammonia. Have you ever seen the color of ammonia gas? No, right? Well, that is because ammonia is a colorless gas. Another interesting thing to note here is that ammonia has a pungent odor. It even has an alkaline or soapy taste. Note that when ammonia is inhaled suddenly, it brings tears to the eyes. It is important to note that because ammonia is lighter than air, it is collected by the downward displacement of air. We also know that ammonia is highly soluble in water. Let me now describe to you this solubility feature of ammonia. 1 volume of water dissolves about 1300 volumes of ammonia gas. It is due to its high solubility in water that the gas cannot be collected over water. Ammonia can be easily liquefied at room temperature by applying a pressure of 8 to 10 atmospheres. Liquid ammonia freezes at 195.3 Kelvin, that is minus 77.8 degrees Celsius. It produces a white crystalline solid form. If we introduce a burning candle into a jar filled with ammonia, what do you think will happen? Well, the candle will be put off. From this, we can conclude that ammonia is not a combustible gas. It does not support combustion. Let us now introduce a moist red litmus paper into the ammonia gas jar. Notice the change in litmus paper. It turns its color to blue. This shows that ammonia is alkaline in nature. To check the basic character of ammonia, let us perform another experiment. Dip a glass rod in hydrochloric acid. Take it near the jar containing ammonia. The jar should be covered with watch glass so that the ammonia gas does not escape. Slowly slide the watch glass. Ammonia escapes out and forms white fumes. We can see here that when ammonia reacts with hydrochloric acid, it forms ammonium chloride, seen as the white fumes. If this experiment is repeated with the glass rod, now dipped in sulfuric acid, it forms ammonium sulfate. But what happens when ammonia reacts with oxygen? Well, let me explain it to you. Nitric oxide is obtained when a mixture of ammonia and air is passed over platinum rhodium catalyst at 800 degrees Celsius. When nitric oxide is further oxidized, it forms nitrogen dioxide. To form the acid, nitrogen dioxide is dissolved in water. Hence, it forms nitrous acid and nitric acid. Now let's see what happens when ammonia is passed over cupric oxide. Let's see what happens when ammonia is passed over cupric oxide. If ammonia is passed over cupric oxide, it forms nitrogen. A very interesting reaction occurs between ammonia and chlorine. With a limited amount of chlorine, nitrogen and ammonium chloride are formed. In the presence of excess chlorine, nitrogen trichloride is formed. Ammonia forms metal hydroxides which are insoluble and form precipitates. Let us look at some of these examples. If we take ferric chloride solution in a test tube and then add ammonium hydroxide to it drop by drop, we will notice a brown precipitate is formed. This is ferric hydroxide. Similarly, if we take aluminium sulfate and add ammonium hydroxide drop by drop, we will notice that aluminium hydroxide is formed. Take copper sulfate solution in a test tube and add ammonium hydroxide drop by drop. You will notice a blue precipitate. This is copper hydroxide. When we add excess of ammonium hydroxide, the blue precipitate redissolves and gives a deep blue solution of cupramine hydroxide. Let us repeat this experiment with zinc sulfate. When ammonium hydroxide is added drop by drop, you will notice a white precipitate. This is zinc hydroxide. When excess of ammonium hydroxide is added in zinc hydroxide, zinc amine hydroxide is formed. When ammonia is passed on metal at 848 degrees Celsius, it forms metal amide and hydrogen. For example, when ammonia is passed over sodium, it forms sodamide and hydrogen. Now, I will tell you about some of the uses of ammonia. Ammonia acts as a refrigerant in ice plants. Ammonia is used in the industrial preparation of nitric acid by Ostwald's presses. Fertilizers such as ammonium sulfate, ammonium nitrate, ammonium phosphate and urea are manufactured with the help of ammonia. Ammonia is also used in the manufacturing of sodium carbonate and sodium bicarbonate.